All right, here we go. Video number 4 for Math 565M, November 11th, 2021. Can you believe it? It's November and the time change happened and it's dark outside. Oh my gosh. Anyway, all right, so here we are. We're going to take another look at the problem solving cycle. We're going to be looking at this through the lens of grouping problems. We are also going to be thinking hard about how and what implications this has for our lesson plan. So just as a reminder, the problem solving cycle is as follows. So you're going to do student work analysis, or you're going to look at the scope and sequence and the standards, and then you'll design a task for your students that is rigorous, that they don't know at first glance how to solve. Then you're going to anticipate the types of strategies that students might use to solve those problems, just like we did when we did the open strategy share work this past week. You're going to design an unpack or launch that helps students to contextualize the problem and make sense of what's happening. And this might even include an aspect of what is reasonable and what's not reasonable. Embedded in your problem solving period, you will also include think time for students, possible options for turning and talking about strategies, perhaps sharing solutions later in the time. You want to make sure that you give students a space for productive struggle, which is a space where they're going to grow the most, where their brains will be stretched, and where they're going to use something they know to figure out something they don't. This all happens during the solving time. And of course, you're going to confer and monitor using the questioning strategies that we've talked about in weeks past, asking clarifying, eliciting, supporting, and extending questions, and also being very, very specific with the noticings and wonderings that you have about student thinking, both written, using manipulatives, and verbal interaction. Finally, like we did last week, you'll take a look at your student set of work. You'll select 2 to 3 pieces, maybe 4, depending on the age. You'll sequence those pieces of work to facilitate a share where students can make connections from one strategy to the next. This leans heavily on the strategy progression that is research-based that we've discussed over the course of the semester, direct modeling, counting, and then invented algorithms. And then you'll have the students as the authors of their strategies share, and you might use annotation tools and perhaps some strategic questions to help students make connections and clarify the students' thinking for others. But ideally, we would want the students to be asking the questions and identifying those connections on their own. So that is really important for cognitively guided instruction, that we understand what this looks like. Here are the components of a math block and the approximate timing. Now, of course, you may decide to put some of these at separate times during the day, and that is fine. But this is a general schedule of how much time you should be working on the math daily. So 5 to 15 minutes for a number sense and reasoning routine, 5 to 7 minutes for the launch or unpack and a turn and talk, and then 15 to 20 minutes of think time, productive struggle, solving time. This can be independent, partners, small groups. You will be conferring and monitoring and selecting and sequencing. Now, if your students are older and the problems are more complex, you might extend this time, particularly if you're in middle school or high school and you have block scheduling. You might have a longer period to administer those problems. You might also do a little bit of work, a share, a little bit of work, and a share. So that is completely up to you. These are just recommendations. I personally do my number sense and reasoning routines for first and second grade in the morning, in our morning meeting, and then we have a solid 45 to 50 minutes in our math block that's uninterrupted. And then you want to make sure that you leave 15 to 20 minutes for the share at the end. Now, again, you can also structure your problem solving block where perhaps you start your problem solving block outside of your number sense and reasoning routine with the share from the day before, just depending on how the timing goes for you and how proficient you feel at orchestrating the share sort of in the moment. Remember, you can always plan these blocks strategically and allow space for a break or a recess or PE or something like that to give you the time and the space to orchestrate the share. But don't forget it. It's very important. So now we're going to move on into problem solving together. So let me do a little unpack with you. So this is Grandma. We've met some grandmas earlier in the year, and this grandma also likes to bake. And here she is with some cookies that she has baked. She has some plates that she is going to put the cookies on so that she can have enough cookies for all of the people that she is inviting over. And here are the delicious cookies that Grandma is going to make. So, mathematicians, I'm going to talk to you about this problem right now. And I'm going to tell you that it's not a differentiated problem because I want us all to be talking about the same kind of numbers, as this is our first foray into grouping problems. When you see it, I want you to really make sure that you take time to think about what the problem is asking and what is happening with the cookies and what is happening with the plates. As you can see, when you look on this plate, there is one plate, right? How many cookies do you think might be on there? It's kind of hard to tell, isn't it? Because we don't really see how many are in the back. So let's just take a look at our problem today. Grandma has 13 plates with 21 cookies on every plate. How many cookies does Grandma have? So let's think about this, mathematicians. How many plates does Grandma have? And how many cookies are on every plate? Great. If we were going to figure out how many cookies Grandma has, do you think she's going to have more than 40? Why or why not? Do you think she's going to have more than 100? What makes you think that? Do you think she's going to have more than 200 cookies? Mathematicians, I want you to be thinking about this, and here is your task. I want you to solve the problem in two ways, and I really want you to stay away from the standard algorithm for multiplication. I'm going to invite you to post on a Padlet and include your name on the post. Then take a quick movement break. And we're not going to be able to do an open strategy share because we're here in asynchronous land. But do take some time on Thursday evening to look at the Padlet because it'll be fun to see the strategies. So the Padlet is here, and I have also placed it on your sheet for you right here. This is the Padlet. And here is the problem as well as the cookies here for you. So have some fun with this, mathematicians. Maybe you'll even have a cookie while you're working. I'll see you soon.